30 minutes, and then we'll have some time for you guys to ask questions. I've got some questions here that were submitted before the talk, so I'll try to put those in as you guys are asking questions live. So while you guys are watching the presentation, if you guys come up with questions, write them down or remember them, and we'll have time after her presentation to go through them. I want to thank everybody that has been participating in the challenge. If you guys can see me, I've got mission patches behind me. We've had a lot of fun looking at your guys's mid-challenge submissions. We've really enjoyed seeing what you guys have done so far. So I hope you guys are enjoying the work. Okay, so Angela Garcia is here joining us today. She is a exploration geologist, which sounds pretty exciting to me. She works at Johnson Space Center, which is in Texas. And she's actually, she's a fairly early career, a young scientist, which I think is exciting for us to hear from. She got her degree in geology from the University of Nevada in 2017. And she actually got her master's degree in geology from Idaho State University in 2019. So some of you guys are from Idaho. So she also spent some time in Idaho as well. And I'll go ahead and hand it off to you, Angela. Thanks for joining us.
Yeah, thanks, Darcy. I'm so excited to talk to you all today. It's great to see where you guys all are from. Yeah, I'm Angela Garcia, exploration geologist, planetary geologist. I work for Jacobs Technology, which is a contracting company at NASA Johnson Space Center. And I'm going to tell you guys a little bit about the work that I do to help prepare for human exploration on the moon with Artemis. But I'll start by saying a little bit about myself and where I came from and some of my career journey to get here. So let's see. I grew up in Hawaii. I don't know if any of you have been to Hawaii, but that's where I grew up on an island called Oahu. It's in the middle of the Pacific Ocean. It's a really beautiful place. Some pictures on the left. So I grew up just always surrounded by nature, you know, big mountains, ocean, stars, you know, on an ancient volcano. The big island of Hawaii has active volcanoes. So I'll just say that in my free time, I was always hiking and being outdoors. So I think it really, you know, I was always curious about nature, and that's really kind of what led me to science, and specifically geology, because I always want to be outside. And so geology is the kind of study of earth processes and rocks are outside. So it's one of those sciences where you can be outside. And yeah, so learning about the earth and beyond is where I got that beginning. And, you know, when I went to college, I took a geology class, and that's when I went from kind of an environmental science to geology. And then I learned about planetary geology, which is studying rocks, not just on Earth, but on other rocky bodies like the moon and Mars. And that's when, you know, that curiosity in my brain went to exploration of different rocky bodies, and the rest is history, right? So I followed what I really love to do, and it led me to being really happy in what I do every day. But yeah, so I went to elementary, middle, and high school in Hawaii, and then I went to college at the University of Nevada, Las Vegas. I got my bachelor's of science in geology there. And there I did a lot of undergraduate research. I studied the chemistry of Martian soils, did a lot of research that's not the research I do today, but it was really helpful to get me to learn more about the fields of planetary science and planetary geology. And then after I got my bachelor's of science, I did an internship, a summer internships with Jacobs Technology at NASA Johnson Space Center. Big proponent, or very pro internships, because it really helps you understand what, you know, working in a field that you're interested is like day to day. And so, you know, like those internships are really what helped me get the job I have now. Even though I was doing different work, I was doing experiments in a lab. I learned from the different people there what other jobs are available in that field. So if you ever see internships, you know, they're really great opportunities. Let's see. After my summer internship, I did a Master's of Science in Geology at Idaho State University. Go Idaho. Idaho's really beautiful. So is Nevada. And that project was really cool as well. I worked on a team that used remotely operated submarines to explore the floor of the Pacific Ocean. So there's a picture on the lower right-hand corner. We're using submarines to explore active underwater volcanoes. And that was really awesome. And so that was a way that I did some exploration when I was going to school. And that really helped ignite kind of a pathway to working Artemis. But I did a year of graduate school to get my Master's of Science in Geology. And then I actually took a break and did another internship because I just love internships. But that internship really helped kind of work into different fields at Jacobs. Actually worked part-time there. And then after I graduated and I went back to Idaho to finish my degree, I was employed full-time at NASA for Jacobs technology. Yeah, so that's kind of the the pathway of how I got to the job that I have now, which is a planetary geologist, exploration geologist, working Artemis. Okay, so let's talk about Artemis a little bit. I think you guys already know a little bit about it, but it's NASA's series of missions to get humans back on the moon. So the work that I really support is Artemis 3 and beyond. If Artemis 1, if you haven't been following, happened late last year, where they tested a newly built rocket, and so Artemis 2 will then be taking a similar kind of rocket or putting humans on it and orbiting the moon. And then Artemis 3 is going to be when we take that rocket and a different rocket and then land on the surface of the moon. So that's a lot of the missions that I'll be supporting, is when we get humans back on the surface of the moon. And so, like I said, I'm a geologist, I'm a scientist. I'll say a lot of the people that support Artemis are engineers, right? Because they're the people who are building the spaceships, they're building the spacesuits, they're building the tools, they're building what's called hardware, and they're building it to help scientists and humans explore. But they need scientists to be involved in that kind of building of hardware for us to have a successful mission, right? So, scientists and engineers tend to have a little bit of different perspectives. So as a scientist, I'm observing, I'm collecting data, I'm creating hypotheses based on that data, and then changing my understanding of the world around me. All the questions that I have, as scientists don't have answers, but they're collecting data and they're changing their understanding. Engineers, they're building things and they're creating things, and they know what's in there because they built it. They know what it is. They have a lot of their questions. They have answers. And so it's just a little bit of a different mindset. And so I live in this kind of gray space of engineering and science, where I'm a scientist in an engineering world trying to help everyone be successful in that landscape. So these are the kind of the 4 categories of work that I'll talk about that I support with Artemis as a scientist. So field testing, so that's doing these, tests out in places that are lunar-like with big teams, and we're doing essentially practicing exploring the surface of the moon by exploring different places on Earth. And then science operations testing. So if you think about that as like a mission control, and putting science into mission control and how people communicate with each other. I also help to test hardware. So that's like human test subject type of work. So you have scientists that are testing the spacesuit and testing the tools and giving feedback to the people who are building it to make everything better. And then geology training, where we teach, right? We teach engineers and managers and astronauts and astronaut candidates, and really the people who are going to go, the astronauts that are going to go to the surface of the moon will have hundreds of hours of geology training. And so that's the types of work and the types of groups that I help with day to day. So let's get into see some cool pictures, huh? Okay, so let's start with some field testing. So, so here's a, hopefully you can see that video. So really that's just, we're going to to places on Earth that are in some way like the moon. So this is a video of Iceland. Place in Iceland, you can see there's these different shades of gray. You have big rocks, you have small rocks, they're jagged, some are round. It's covered in this kind of sediment or this regolith or soil, and you don't have trees. Like these are all things that are lunar-like in some way and a great place to explore. So for these types of field tests, we have, a big team of people, and we, pick a place on Earth and we plan, right? We plan, so how are we going to explore this area? So we plan and we plan and we plan. I can change the next one. We plan, we plan, and we plan, and then we get people to go out and execute that plan. And then we learn, and so those people who are going out and they're doing the plan that we set, they have cameras, they have videos, they have lights, they're on the radio or on they can talk to us back at mission control. So, we're really trying to simulate what it would be like to explore the surface of the moon by going to these locations. And then you have a group of people back on Earth that are seeing what somebody out in the field is seeing and listening and learning and changing our understanding of what we thought it was going to be like in real time. And we're trying to learn how to communicate with each other and maximize the success of the mission. Anyway, so here are some cool pictures from different field testing. So if you notice, on the lower right corner, there's some pictures of tents. So a lot of these locations are remote. And so we go out there and we set up a base camp. We camp for weeks. One of my favorite parts, because on my off days, I'm already camping. So it's like I'm not even working. And then also, if you see some of these pictures are taken at nighttime, we do a lot of these tests, not in the daytime, but in night, because we're going to be landing on the south pole of the moon. And it has really complicated, the moon has really complicated lighting at the poles. The sun is grazing the surface. And so you have these long, dark shadows. So we want to really practice how we would do an Artemis mission by having complicated lighting as well. So we bring a fake sun out into the middle of nowhere. We have lights on ourselves. And so we're practicing trying to explore and do science and learn under all these constraints, right? And so you can see a picture of me. I'm in this shell, this spacesuit shell, and that's because it's hard to move in a spacesuit. And so to be more realistic, we put on this kind of outer spacesuit shell, so we can't do everything that we think we can do here on Earth. And so those are just ways that we do these types of tests out in the field. Okay. And so on the other side of that is what's called science operations, right? So that's the mission control side of these types of tests. So you have a group of people out in the field that are doing your plan, and then all the video, the pictures, everything that they're saying and describing. So the astronauts that are on the surface doing, exploring the surface, you can hear and see what's happening in a simulated mission control. So I'll also say that for the International Space Station, when they're called flight controllers, they help direct, and the astronauts who are doing spacewalks, they're all engineers, right? Because there's no need for exploration on the International Space Station because we built the space station. We know exactly every screw that's up there. We know where it is and how much you have to turn it to tighten it, right? So you don't need to have scientists as a flight controller in that type of world. But for Artemis, we're exploring the surface, right? We don't know all the answers. And so you need to bring scientists in this communication loop so you can all work together as a team to learn about the surface and to learn about the moon, and for everyone to be safe and to navigate and all this good stuff. And so that's why it's really important to bring scientists in and to do these tests with a big inclusive team. And so really what this work looks like is looking at a bunch of screens with a bunch of different types of data and listening and talking on headsets and talking with the team it's on the surface. Yeah, I threw this in here last minute, but I just want to say that we also do work with virtual reality, right? Like not everything that we need to learn is going out into the field. You can also learn about how we communicate each other with some people in virtual reality. And we have virtual reality scenes of the moon and of different places on Earth. And so just know that there's a lot of different tools that we can use to learn about Artemis. And this is a really fun one. So another type of work, it's called hardware testing or being a human test subject. And so that's when, so like as a geologist, I'll help to test spacesuits and hardware, like geology tools. So the geology tools for Artemis would be things like hammers, shovels, chisels, rakes, scoops, things that we all do day to day, except they're very specific. They're very specifically designed. And so we can provide different feedback as a geologist on what's comfortable. So a geologist would bend down and want to get really close to the rock, and maybe an engineer wouldn't be in a certain position, but that's what would make sense for sampling a certain type of rock. And so the type of feedback that we provide. So this is some pictures of me in what's called Argos, which is a kind of it's a spacesuit that's attached at the back to like a large crane, and that crane has a computer on it that can predict your movements. And so what it's doing is it's pulling up and offloading the weight of the spacesuit into 1/6 gravity. So it's lunar gravity. So essentially every step that you take, the crane will lift it that opposite amount. And so you can bounce around on the surface like you would on the moon using this type of equipment. And this spacesuit really helps understand like what types of movements you could do while conducting science out on the surface of the moon. So this was really fun. And then finally, geology training, right? So I talked a little bit about how scientists, or about how a lot of people who support Artemis are engineers. And as a scientist, we can help teach engineers and managers and astronauts about the scientific process, right? So not even, so for some of the astronauts, we'll teach like advanced geology and very specific types of curriculum, but for general managers, engineers, it's just understanding the scientific process. How do you make observations? How do you, really helping to people understand, a rock isn't just a rock. A rock from here is not the same as a rock from there. And this is why it's worth going to maybe this farther location because of all the science that we can get out of it. And about how, we can make all these plans, but when you're there on the surface, or you're there at a place that you've never been before, you'll learn different things and you'll observe things that might make you want to change from the original plan. And so you have to stay flexible. And so those are the types of things that we help to teach to people at NASA. Yeah, and so we're training, and the astronauts for the next Artemis haven't been selected yet, but when they do, they're going to take hundreds of hours of geology training. And so we're building that now. And we're going to be making sure they're all trained up, and anywhere they go on the moon, they're going to kick butt and do awesome geology. Yeah, I think that's all the slides I had, but just wanted to end with, this is a really exciting time right now for human spaceflight. And so it's really awesome that you guys are interested and that you're here. I'm really happy to answer all your questions. But yeah, we're the Artemis generation, guys. So, Artemis is going to be tens of years. So it's going to be a really fun journey to stay in the loop, and let's hopefully answer some of your questions.
Hi, Angela. Thank you. That was awesome. I think I've seen a few of these talks. You might have the coolest job of anyone I've ever seen, because
Yay!
you actually get into a spacesuit, which is amazing. I'm jealous of that for sure. It's like you're at space camp every day. Sounds kind of awesome. So thank you so much. Those are excellent photos, and yeah, your job sounds really cool. Makes me wish I could go back and do geology.
It's never too late.
Yeah, it's true. It is never too late, but it's definitely not too late for the students that are joining us today. So I hope a lot of you guys were inspired by that talk to ask some questions. I see a huge hand going up in Gary Brandt's classroom. So we'll just go ahead and get started with questions. So teachers or whoever's on your computer, just unmute when I call on you. You can ask questions. I think you guys should be able to use the gestures. So I think you can raise hands if you know how to use the reaction feature. I'm going to raise my hand right now. I think that works. Oh, I guess it just does it with your hand here. Then I can see that your hand has been raised. Okay. So yeah, Gary, go ahead and have your student ask the question.
Marvin's a little bit far away from the microphone, but he's saying, when are we going to the moon?
Yeah, good question. So right now we're aiming for late 2025. So not that much longer. But Artemis 2, which is when astronauts are going to get into the rocket and go around the moon, that's going to be in 2024.
2020. Great. Thank you.
You going?
Yeah, Gary wants to know if you're going, Angela. Are you?
When am I going? Oh,
Yeah.
yeah, I'm very happy to help the astronauts get there.
Fair
By
enough.
proxy.
Okay, we've got a hand up in Sarah Turner's class. We'll go there next.
Hi, we have a student that wanted to ask a question. Allie, which question did you decide on?
I don't know.
Okay, I like the one that you asked for the second one the best. She wants to know, why are we doing the moon, and then why are we doing it now?
Yeah, why are we going there, right? And you'll get a lot of different answers. I'd say why I feel like we're going to the moon. It's inspirational, right? It's a new endeavor. It's uniting, right? Human beings together, exploring a different planetary body. But there's also like economical benefits and like sociopolitical and geopolitical benefits. But I think it's because it's cool and it's awesome and it's inspirational, and we get to do it together. And we're doing it now because this is the soonest we could have done it. It's hard to do this type of work, so we've been working towards it for a really long time.
That's great. Okay, I'm gonna go to Oscar's class next. We can deal with the echo if you guys.
Maybe the chat.
I think if it's a short question, we'll just skip the echo. It's up to you. I'll open the chat. Okay, let's see. Do I see it? Let's see. Is it in the chat already, Oscar? I don't see it. No. Did I miss it? Let's see. Let's switch over here. Well, I'm trying to find that question. How about Eli and Leah? Do you want to unmute and ask your question?
How is Artemis going to help us go to Mars?
That's a good question.
Yeah, that's a really great question. So we're going to go to the moon and we're going to go to Mars. There's a lot of, so Mars is really far away, right? And one of the most reasonable ways that we can get to Mars is if we actually launch from the moon to go to Mars. So that's one more like realistic way of how Artemis is going to be able to get us to Mars. Because if we can go to Artemis and we can mine resources like water ice and it creates rocket fuel, then we can much more easily get the far distance that it's needed to get to Mars. And also we haven't kind of lived and explored on a planetary body in a really long time. It's been over 50 years. And so there's a lot that we still need to learn. And like I said, Mars is really far away. And so that extended time in space is really hard to do. So by going to the moon and by working on Artemis and having people learn how we can live safely on another planetary body for an extended period of time, that'll really help us get to Mars and to do it safely.
That's great. Okay, there's a couple of questions in the chat, so I'll go up here. Oscar student's question was, what are you going to explore on the moon? So maybe, yeah, when astronauts go to the moon, what in particular are they going to be looking to explore?
Yeah, there's so many things. Look at all the rocks that are there. So we've never actually been to the South Pole of the moon. So it's a completely new place that we haven't gone to. We've gone to kind of the center or the equatorial sites on the moon, but we've never been to the South Pole. So there's a lot of different types of rocks that we've never seen. And those rocks will give us a lot of information, not just about Earth or not just about the moon, which can help us learn a little bit about the Earth's history and the history of our solar system. So we'll look at the different types of rocks. We'll look up in craters and look at potential volatiles or ice that's in these different environments. So like the coldest place in our solar system is actually deep in craters on the moon. So there's a lot of different types of things that we go and explore there because we've never been.
That's great. Okay, more questions from the chat. People are being shy about unmuting. Don't be shy about unmuting and asking. It's more fun if we get to see your face. But okay, so from Puerto Rico, this is a good question. And again, just an opinion. Will we ever be able to travel to the moon as if we were traveling by plane at a fairly reasonable price? A hard one to answer.
You know, maybe in like, I mean, hundreds of years, maybe. I'll say spaceflight right now is very expensive. So at a reasonable price, I don't know. Not maybe in your lifetime. I don't know about mine, but maybe in yours. But I will say that NASA has kind of changing their perspective on how they're going to how they've been doing kind of exploration in space. It's just that they're putting a lot of investments, or they're putting a lot of money into commercial companies. And so they're trying to help like build a space economy. And so NASA is government funded, right? And that can change depending on political situations. But if NASA puts money into different companies, like American companies that have the capability of going in doing work in space, then that becomes a much more reasonable option. Because if you have kind of a lot of ways and different creative answers to space travel, hey, that's when things become possible. But yeah, so fingers crossed, you and me both. Hey, if it's cheap to get there, you bet I'll be there.
Yeah. So as long as it takes a rocket, you guys are going to have to come up with something different than a big old rocket to get to the moon. Okay, this is a little bit of a longer one. So, but it's a good one. So, hold on. Geologists typically like to look closer at rocks or even use magnifying lenses to see details like minerals. How difficult was it to do that with a spacesuit on, or how difficult do you anticipate that being? Will the space geologists have to pick up rocks that kind of look interesting, or will they be able to choose carefully without maybe picking them up?
Man, that's such a specific and awesome question. And something that we like literally deal with and are trying to grapple with, right? So yeah, a field geologist on Earth has a lot of tools at their fingertips, like literally their fingertips, because they can actually move their hands really well. An astronaut in a spacesuit, it's like almost like wearing oven mitts. Like it's really hard to do much of anything with your hands. You can grip a hammer and you could press buttons and you can do things like this, but we won't be able to hold a magnifying glass. We can't have what the geologist uses a hand lens. We can't use a hand lens, at least not what we think right now. Maybe we have like a little magnifying glass on the outside of the helmet, and then you could put a rock up to that. A lot of things are still being decided right now. But yeah, so like, how do you pick what's a good rock, right? Especially everything is covered in this really fine dust. It's tough. And that's where the geology training comes in. We'll have a lot of plans and a lot of science schools of about what we're going to be looking for. But yeah, a lot of it is like, does something stand out? Does certain samples cover what the scientists are looking for? And then also when we have more capability, when we have more geology tools, you can bring, handheld instruments that can, you can hold it up to a sample and zap it, and it can tell you the chemistry or the mineralogy of a rock. So eventually on Artemis surface missions, we'll be able to have more sophisticated tools versus just a hammer and a chisel. But right now for the first landed Artemis, we're going to be just having the kind of old school hammer and chisel, based on the astronauts' judgment of what they think a good sample is going to be. But yeah, it's going to be, you can't really see minerals, covered in dust, kind of in the dark really, but it's a really good question.
Yeah, I'd be interested to see what the students could come up with to solve that problem. Maybe you guys can put a big helmet on, put some gloves on, and go see what you can do outside. Give yourself a test. All right, how about we'll go to Doree's class. I see a hand up, patiently waiting. Go ahead and unmute yourself and ask your question.
Carson, I was curious as to our classes were given a synthesized version of Regolith to kind of mess around with and test. I was wondering how did you make that and how long did that take? What is the development process? Does that look like?
Yeah, so the question is about lunar regolith simulant, right? So, it's really hard to actually test with real lunar soil, right? Lunar regolith, but really a lot of what is made up, what lunar simulant is made up of, or lunar soil, I should say, is made up of, are volcanic rocks that you actually find on Earth. So you can crush and powder rocks that are of similar composition or similar types of rocks or mineralogy of what we have found on the lunar surface. And so that what that really means is a lot of times to just using big machines to crush those similar rocks, and then adding other things to it. There's a lot of different kinds of simulants out there, using volcanic ash and glass beads, and there's a ton of stuff. But yeah, it takes a while, and they have to make big batches because it's a lot of material. But they're earth materials.
It takes years to develop something like that, or?
No, not necessarily. It really depends on the type of simulant. But say if you wanted to have a small batch of simulant, you could get the rocks that you need, and then you could crush that up. That's a simulant, right? You can do that. It wouldn't take years to do that.
Thank you.
All right, Marina, do you want to ask your question, or do you want me to read it off the chat? You've had your hand up for a little while. Go ahead and ask it.
Read off the chat, please.
Okay, fair enough. Okay, so that question is, which is a good one, how sticky is the moon's regolith?
How sticky? Yeah, pretty sticky. And sticky in the sense of it's not like gum sticky, it's electrostatically sticky, as in it wants to stick to stuff because of different electrostatic properties. And pretty much it was on everything. When Apollo went to the lunar surface, it was a huge pain to clean and get off. It would stick to pretty much everything. So in terms of that, in stickiness, very sticky. And there's a bunch of people working, it's called lunar dust mitigation, working how do we get people clean, because astronaut time is really important. So how do we minimize the time that they have to use scraping and brushing and vacuuming and all of that, because they'll have to bring it into their habitable volume. They're gonna have to bring it into their kind of where they're living. So yeah, very sticky, very hard to deal with. Big problem that we're working on.
I got an idea on how you can get rid of it. What if you charge it the part that got stuck on with the same static electricity that it is, that repels it instead of attract?
Yeah, so they are working actually a lot of that too. There's coatings that you can put on stuff that are electrostatically help repel. You also have things that are actually they're called active. So it has power, and then you can turn it on and it can repel dust doing that. But again, power is hard to come by, right? Like things that you have to turn on and use. And it's just tricky, right? But yes, that is totally a great idea, because it's like almost impossible to brush the stuff off. So they're probably going to have to use some sort of electrostatic gun or something like that to be able to get rid of it. But that's hey, if you're interested, that's a whole field of study. So
just to add on to what you were saying, is it a lot like sand mixed with flour?
are you talking about lunar regolith?
Lunar regolith, yes.
So it's like, well, how it literally is, it's you take a rock and have it pummeled with meteoroid impacts for billions of years. And so it gets pummeled to powder, but then every impact is really fast. And so it can melt parts next to it, and those melts cool really quickly. And so it becomes glass. So you have bits of sharp glass that are melded together, remelted, smashed again. So it's sharp and jagged, and it's actually really glassy. But it can be really fine, and then have clumps of other fine things that make these really sharp little jagged things. So yeah.
You have to be a little bit careful with it, guys. It is not the best material to be inhaling necessarily.
Yes. Yeah.
This is a little bit out of your expertise, but hopefully you can answer it. We've got a question in the chat. Is Jupiter pulling the moon away from us? If yes, then will the rest of the planets be next?
Whoa, that is, aren't you a physicist, Darcy?
I'm a physicist. I can answer that if you want.
There you go. Answer that for me.
Yeah, that's more of a physics question. Jupiter is not pulling the moon away from us. Jupiter wreaked a lot of havoc in the early solar system, but for the most part, it's done wreaking havoc and moving planets around. But it is have incredibly strong gravitational field for sure. So, but yeah, we don't have to worry about it pulling the moon away from us. But the moon is moving further away from us, but that has to do with a physics thing called conservation of angular momentum, which hopefully you guys will get to learn about soon, if you haven't already learned about it.
Nice.
Okay, we've got, oh, that's a hard one. Hold on, I'm going to switch to one of these early submitted ones because one of them is kind of fun. So I'm assuming this is from a team, maybe from Idaho. We do have quite a few teams in Idaho. This is a many-part question, so maybe I'll just ask this first one because it's an easy one. Have you ever been to Craters of the Moon National Monument and Preserve in Idaho? And have you ever trained there?
I have been there. I was there for field work when I wasn't working for NASA, but I've totally been there. That is not very far from where I used to go to school. And it's so cool. It's very awesome.
Yeah, put it on your list if you have not been there.
Super cool.
Let me ask another question from the same team. Let's see. So I guess this one is generally just about, and I know you talked about tools in your presentation, but maybe I'm going to paraphrase the question a little bit. So like, how do you decide which tools to select? Like, do you guys have a bunch of tools that already exist, maybe from past missions, maybe the Apollo missions, or are you specifically creating new tools for the Artemis mission? And how often do they change as you're practicing in training?
Ooh, good question. So I'll say for Artemis 3, one of the baseline tool sets it started from the baseline tool sets from Apollo. So the rake, the chisel, the hammer, the scoop, all those things were baselined in Apollo, and we've made tweaks to them since then. And so that's for first landed Artemis. And so like learn from like what worked and what didn't work, and then using them again over and over and seeing what we can do better. For new tools and things like that, that would be more for maybe Artemis 4+, which those are the more sophisticated tools, like the handheld, what's called an XRF or an XRD, so X-ray diffraction or X-ray fluorescence, or micro imagers and all. There's a ton of really cool handheld tools that are really technologically advanced that is being developed, and that's being developed by different teams, and then they come and test it. And so those are new tools that are being worked, and those are still being worked.
Very cool. That makes me wonder. I'm gonna ask my own question because I'm the boss here.
I have a question.
Well, who's got a question? Someone's
I
really
have a
eager?
question.
Go
I have a
ahead.
question. What kind of minerals and like useful materials, industrial minerals, and all that kind of stuff can be found in the lunar soil?
Yeah. So what kind of minerals are in the lunar soil? Yeah. So there's things like olivine, pyroxene, plagioclase. There are actually a lot of minerals that you find on Earth in basalt. So there's volcanic rocks on the moon. That's what most of the moon is made of. Basalt and anorthosite, and those minerals are what consist of the mineralogy on the moon. And so other, like, in terms of like things that we can use as like resources, maybe if that was a part of your question, I think a lot of those are more of like what's called volatiles, or like the frozen. Yeah, those. Yeah, so that would be like ice, right? So water ice that's deep in craters that never see sunlight. So these are places that craters are formed where you have impacts, so meteoroid impacts onto the surface, creates this big hole. Meteoroids have ice in them, and so they're deposited when they smash into the surface and create this big hole. And then on the south pole of the moon, those craters never see sunlight, and so they stay deep and they stay cold, and the water ice never escapes because it's just trapped there. And so those are the kind of resources that we can go and find and use in a more industrial sense.
I have an idea. Couldn't the lunar regolith be used like cement or concrete?
Yeah, sure. So you could do something of like, you could melt. If you had a lot of heat, you could melt the regolith into, say, bricks and things like that. Like there's a whole field of study also. It's called in situ resource utilization. That maybe I could type that in the chat, but that's a whole field where you use the resources where you are at to build. And so that would be like sintering and melting regolith to make building materials and shields, like radiation shields and all that really cool stuff.
Very cool. Good question. All right, we're going to switch over to, I know you guys put it in the chat, but if you guys would like to unmute and ask your question, the Flaming Llamacorns, one of the great names of Nesby here. Great team names. Do you guys want to, go ahead. Yep.
Is the carbon dioxide buildup more of a concern than not having oxygen?
Oh, interesting. Both totally a concern, right? This isn't my field of study, but I would think that if you had too much carbon dioxide, that it's poisoning you. So you would want, like, that would be more of a concern. So I would say both totally a concern, and removing the carbon dioxide, I think, super important. More important.
All right, we're going to switch to Sophia Rodriguez. You have a good question. Do you want to unmute yourself and ask?
Sure. What's it like working with NASA and the people employed by NASA?
Ooh, yeah, I love it. It's super fun. I'd say everyone I work with is like super smart and motivated. And I mean, I really enjoy it. Yeah, it's a dream job for me, for sure.
Probably can't work with a bigger set of interesting people than you would find at NASA. Let's see, who else has a question? Philip, do you want to unmute yourself and ask your question? I don't know if I can say that last name. Solomentinovic. That's a big last name.
Solomentnikov. And I don't have any more questions. I don't have any more questions. Thank you.
Oh, okay. Gotcha. Okay. Let's see. We'll skip over. Calder, do you want to ask your question?
Yeah. What's etymology?
Etymology? Did I say etymology? I have no idea. Does anyone else? Do you know, Darcy?
Not off the top of my head. Somebody I bet knows here.
Is
Okay,
that a
Google it.
pop quiz question? Oh man.
I was wondering if you said it. I was like, that's a very the study of the origin of words,
Whoa.
which is a funny word to have to look up, actually.
Yeah.
That's a good
It's funny
question.
words.
You stumped us with that one. Okay, we got one more in the chat here. I'll ask quick from Diane Reed's class. So do the astronauts have to learn geology, or do they learn what they need to learn from you and other geologists at NASA? So they learning like all of geology, or are they just learning what they need to know?
Oh yeah, good question. So it kind of depends on what type of astronaut. So for the astronauts that are going to the International Space Station and not the surface of the moon, they'll learn kind of the basic geology. Well, yeah, they'll take a couple of courses essentially. But for the astronauts that are going to the moon, that are the Artemis astronauts, they'll have hundreds of hours of geology, and they'll have thousands of hours.
Folder in your backpack.
What was that?
We'll stay on the Zoom call, okay?
Oh, I think we have an open mic. I think.
Yeah, I think you're right. We'll find it. Here we go.
Cool. Yeah. So astronauts will have thousands of hours of training in non-geology things, mostly how to steer a spaceship and to do crazy things that I have no idea how to do. And then we get their time for anywhere from 40 hours to like hundreds of hours to do geology training.
Is anybody here interested in geology as a career? Nobody? No hands raised? It's pretty good. You get to be outside all the time. I would do it. All right, let's go back to Dory's class. Mostly because I can see your hand physically raised, and I'm worried about the blood like just draining out of your hand. It's raised for too long. Go ahead, ask your question.
Let's see. So like you were talking about how in the South Pole there's ice down there. Like how would you mine that? Or I don't know if that's like really a question, like you just extract the.
No, that's a good question, because we're trying to figure out how do you do that? Probably with robots. I mean, so we have equipment that is rated for humans to get cold, but that's for some of the really deep they're called PSRs, or persistently or permanently shadowed regions. They're super cold, like the coldest places in the solar system. And so likely if you can get robots to help capture that material and bring it and keep it cold and to do what they need to do with it, probably more time efficient and safer to do.
So is that process practical for like if you were to live on the moon and like mine water, would that be something you'd have to innovate to make it more efficient? Or
yeah, so there's a lot of technology that's going to need to be developed to be able to get that efficiency and to see what's reasonable and worth the time. So you'll have astronauts on the moon, but they probably won't be there for the entire time. So there'll be a lot of time where astronauts will be there and then they'll leave. And then there's a ton of time where we won't have anybody there. So if you can figure out how to work with robots and to use them while people are still on Earth and remotely kind of control them, I think that's a really good use of time. And I think that's all like technology that needs to be, and that is being developed.
And then I have one last question. Is there like weathering or erosion on Mars, or the moon, I mean, or like how does that work if there is?
Yeah, so there's no liquid water on the moon. Mars used to be an ancient ocean world, and so you have evidence of flowing water on the surface of Mars, but you don't have that on the moon. But there are things called like space weathering, which is the moon doesn't have an atmosphere or a magnetosphere, so it's very exposed to particles in space. Maybe Darcy can tell you more about space weathering, but so it's bombarded with different types of galactic cosmic rays and crazy things that are flowing through space, but Earth is protected, but places like the moon are not. So the things like space weathering, where you have tons of radiation and you have particles that are bombarding the surface and changing that kind of top layer. So you do have things that are weathered. And then again, the moon is constantly bombarded with kind of meteoroid impacts, very, very small to less frequent, larger ones. And so in that way, you have that type of weathering of the surface. So you have the surface that's kind of moving around and being smashed because of that. And I'll say too, a little science plug, the Earth and the moon are exposed to the same types of space environments. So those meteoroid impacts and the galactic cosmic rays and things like that. But the Earth has an atmosphere, it has a magnetosphere, it has things that are protecting it, but the moon doesn't. So we can use the moon to study the history of all the things that have been happening to Earth, but we just don't see it because the Earth is protected. But everything that's happened to the moon is happening to the Earth as well. Okay, science plug over.
No, it's great. That's a lot of different types of science have to contribute to sending humans to the moon, all the way from physics to geology. Okay, Eli and Leah, you guys have had your hand up for a while. Do you guys want to unmute and ask your question?
Are the spacesuits like the astronauts wear heavy, or are they like?
Oh my goodness, they're so heavy. That spacesuit on Earth, like if spacesuit on Earth is like several hundred pounds. That thing is like 200, 300 pounds. And the only reason I was able to move in it was because of the crane that's attached to it, that's offloading that weight. So it's a sixth of the weight that it is on Earth. So you can't really move around in that spacesuit on Earth. It's really meant to be used in space because you have so much metal and you have so much things that are protecting you from the scary vacuum of space that's a lot of weight. But the spacesuit that we are going to be sending and using on the moon, Axiom is currently building that. So we got to tell them to make it lighter and make it more mobile. But yeah, that thing is heavy, and it's really hard to test with on Earth.
Yeah, hopefully some of you guys saw the news about the new spacesuit, just in the news. Andreas, do you want to unmute and ask your question?
Geology and their plan for the moon, and why is it so important for these people to study and use this?
I might have missed the beginning of the question, but why is important to learn about the geology of the moon?
Mm-hmm.
Yeah. So there's a bunch of reasons, right? I'll say one of the big ones is learning about the moon helps us learn about the Earth. So like I said, it's everything that's happened to the moon has happened to the Earth. We are an Earth-Moon system. So that's one of the really important reasons that we want to study the geology. It helps us understand our place in the solar system. There's a lot of complex environments on the moon. But yeah, it helps us understand just science in general and help us about the geology of Earth.
Very cool. Okay, we're just going to go down the list here. We'll go back to Oscar's class, Oscar Almazan. I need to get better at last names. Go ahead and unmute yourself if you've got a question. Oscar's class.
How many astronauts are at NASA?
Oh, how many astronauts are at NASA? Guess off the top of my head, hundreds, several hundreds, but not thousands, I think is probably my best guess. Yeah, every year they select a new astronaut class, and that consists of about like 20 people. So that's about the rate of how NASA kind of increases their numbers of astronauts, and then people retire. So that's about the rate.
There was another good question from. Oh, go ahead.
When moving in space.
Oh.
Say that one more time. I didn't catch that at all.
Yeah, I didn't catch that either. I'll ask the one that's in the chat, unless Oscar, does someone in the class want to ask the question that is in the chat on video, or do you want me to read it off? Feel free to unmute yourself if you want to ask the question that's in the chat. No?
What have we learned from the ground penetrating radar probes from the moon?
Whoa.
Yeah.
Do you think the
Go ahead.
layers or strata change the depth of the moon, mostly the same stuff all the way through?
Whoa. So that's such a cool specific question. So the question was about what did we learn about from ground penetrating radar on the moon? Okay. And
if it's got layers, or you think it's the same all the way through? Does it have layers like the Earth?
Oh, like
Down.
like deep into the, so we're not talking about just the surface, but like the entire, so the side, like the whole
strata. So maybe just like the crust, but yeah, like do you think there's like, what do you think? Yeah, what do you think's under the surface? Basically, you can just
yeah. So I'll say the deeper you go down, so one, we don't really understand a ton about the subsurface of the moon. We do understand a little bit, but not a ton. And one of the ways we can learn more about the subsurface is by using instrumentation, like the ground penetrating radar and instruments that help detect the seismicity, right? That's a little bit deeper. Other ways is that we have tools that are called drive tubes, where it's like a metal tube that you hammer into the surface, and you can understand the layering that you were talking about, the strata of the subsurface. But you can go like a meter deep. Some of the drive tubes are really big. So you can do that and take it out and then bring it back to Earth and then study this very specific layering. And we actually opened recently a drive tube from the Apollo era recently, because our technology got to the point where we felt very good about dissecting that drive tube. And so we actually did that recently and learned about the different strata. But yeah, that's a big question about that we're going to help to answer with Artemis, is what does the subsurface look like, and what instruments are best suited to learn about that, and what kind of samples can we get to really learn about the subsurface.
Really good question. You guys are thinking like scientists.
Oh yeah.
Yeah, I love it.
Good ones.
I'm going to pass it. Dominique, you had a question. Do you want to answer? Do you want to ask it over video? Dominic? Go ahead and unmute yourself.
You can check the chat. I already put the question right there.
Okay, I'll ask it. This is a good one. Have we seen evidence of another civilization on Mars that you know of?
That I know, that I can talk about, you mean?
Yeah, you might not be able to tell us. Okay.
Not yet. I mean, so a civilization, no, we're looking right now. So Mars 2020, the rover, Perseverance, is looking for evidence of possible past microbial life on Mars, and we're still looking for that. So that'll be a big, be really awesome. But no civilization. Not yet. I think we might have to look a little farther deeper.
Not a totally crazy question, Dominique. They used to think there was a civilization on Mars not so long ago here on Earth.
Hey, it used to be an ancient ocean world. There used to be flowing oceans of water on Mars. So you got the right chemistry for life.
All right, we're almost at time here, so I will let Andreas ask his question. If you want to unmute yourself, and maybe I'll ask one more question that was pre-submitted, and we'll thank the speaker and close up. So if anyone has a burning question that they're being shy about, now is the time, and I'll pass it off to Andreas.
So what's the goal for using geology in a plan for the moon? And
what is the goal for studying geology?
For using geology?
So using it in like a practical building sense, or in terms of like the science?
Yeah.
I think of both.
Building?
Yes,
Both?
and-
Okay.
yeah.
Well, in terms of like like I said, the like in situ resource utilization is all about using the resources that you have where you are. So like on the moon, and using it to build, and using those resources and transforming them into something else. So like, for example, ice is H2O. You can take the hydrogen and oxygen and chemically split that apart and make rocket fuel. You can do a lot of cool stuff with the elements that is within the lunar soil as well. In terms of the geology, it's to help us understand, and learn about the history of our solar system, and about the moon, and about us on Earth. Hopefully that answered your question.
Okay, let's see. I'm going to ask, how are you feeling, Angela? Can you take a couple more questions?
Yeah, let's go.
Okay. We got, Deanna's smiling at me. We always go a little bit over. We've got one more question in Dory's class. Do you want to unmute yourself and ask your question?
How do you guys plan to use drones on the moon?
Oh,
ooh, good question. I don't know if I know how we're going to be using drones on the moon. Like I said, I'm focused really on like the first kind of series of missions. Like we haven't gone to the moon in, like I said, like over 50 years. So there's a lot we still need to learn, but we have a lot of series of Artemis missions that are planned. And so I bet you one of those is going to have to do with, it's going to be robotic heavy and have drones on it. So I think we don't know yet, but could be pretty cool to like do reconnaissance and to look. That's kind of what the drone on the Perseverance rover did. Kind of go out and scope ahead of and not be worried about all of this cratered terrain and all these rocks, but it can just kind of go and look at a distance. So maybe kind of scouting out different places could be something that we could use it for.
All right, I'm going to ask a couple of questions that were submitted early. One, I love these kinds of questions because they're pretty simple, but they're the obvious things that sometimes they're so simple you don't think about it. Why is the moon gray?
Oh, why is the moon gray? Yeah, it's those rocks. That's why it's gray. So most of the rocks that cover the moon are volcanic, anorthosite, and basalt. So there's kind of all these different shades of gray. The basalt or the mare are these kind of smooth, darker patches on the moon. And then the lighter, whiter ones are called the highlands. And that's mostly anorthosite. So it's the lighter colors are the kind of calcium and aluminum. It's kind of why it's that color. And then the darker ones are like the iron and magnesium is why it's a little bit darker. And then the gray, because the kind of white and the light and dark together kind of make a nice gray color.
Yeah, if you guys want to see that, go find, if you got basalt in your area, if you look right on the surface, it's going to be red. You can ask why that is, or like a reddish. But if you go down below, it might start getting gray. Okay, this is another fun one that was submitted earlier. So astronauts bring those 0G indicators on their rocket flights so they can tell when they've hit 0G. Snoopy was brought on the Artemis 1 launch. What would be your 0G indicator?
Whoa, what? What a left field question. Man, I guess I can't bring my dog. That would be against the rules. Couldn't do that. Man, Snoopy's a really good one. I don't know if I have a better answer than a cute little stuffy that's very symbolic.
Yeah, it seems like a lot of astronauts, they'll bring something that's important to someone in their family, like their kids, so they can feel connected. Louisa, do you want to ask your question?
Yeah. Sorry. I just lost my voice for a second. If you did go to space, if you could, would you want to? And or are you good with your job now? Or and also oh my gosh, I lost my
I can answer the first one.
wait, and if you do choose to stick with your job, what's your favorite part of your job that would make you stay?
Ooh, well, I'll say if going to space is on the table, I mean, I'm going to space, right? Like that's pretty hard to beat. I love my job now, but yeah, if somebody was just like, "Hey, Angela, you got to come to space. We need you." I'm saying yes to that. So, I mean, I don't know many people who wouldn't. I guess it would be like you have to be there for years would be crazy, but if it's, yeah, I mean, I'll say I don't envy astronauts because their day-to-day is very busy. They're always working and training, and they're like they're working so hard, and they're very like they're such a high functioning person. And I'm a little bit more laid back. But hey, if the option's out there, I'm coming.
What is your favorite part of your current job?
Ooh, my favorite part, man, something about being able to go out in the middle of nowhere and camp and work and be able to figure out all those little details about how do we actually explore another planetary body is hard to beat in my book.
All right. I love that as a final question. That's a great question, Louisa, I think to wrap up with. Thank you for that good question. Everybody, please take a moment and thank Angela Garcia for taking some time out of her day to join us all the way from Johnson Space Center. Thank you. We really enjoyed that.
Thank you.
Thank you.
Thanks, everybody.
That was amazing. Okay, we're gonna go ahead and wrap it up there, guys. I saw one question in the chat about hanging the inflatable moon and Earth. You don't have to hang them over the map. You can hang them anywhere. That's just a quick answer. Hang them wherever it makes sense. Doesn't have to be right over the map. But yeah, thank you guys so much for joining us. We'll have an office hours next week if you have questions about the challenge, or you can always shoot us an email. We hope you guys are enjoying it. Thank you so much for joining us today, and hopefully we get to see you guys soon. Keep working on your mission objectives.
Good luck, everyone. It was nice to talk to you.
Bye.
Bye.
Hi. Hi. Wait, we're leaving. Are we leaving? Oh yeah, yeah, we are. Okay, bye. Bye.
Hi, Alex. All right. Oh, did Angela already pop off? I was going to thank her again, but it's fine.
Oh, I think so. I'm going to go ahead and stop the chat, stop the feed. Thank you for joining us, everybody.